On Form C, there was one that said solve by to use a differential equation. Which one was that? Like number 4 or 5 on Form C said solve using a differential equation.
I'll fix it if you had. I'll fix it if you just see me after class.
I didn't do so.
I didn't know it was on there. Ooh, that sucks. All right. So, what is arc length? Well, it is two things. This is theta. This is A. This is B. This is C. Think of a piece of pizza. The pizza would be the length of the crust. Okay? So you need to go out here and put arc length equals length of crust. But basically, what is the relationship between the crust and the chord? The arc length and the chord. What is the relationship?
Between the crust and the what?
The chord. Chord, that's the chord right there. We're going to learn that. Somebody tell me what the relationship is. Tell me what you think it is.
Bigger the chord, bigger the crust.
No, well, you're starting it, but no. You're close, but that's not the relationship. Which one's longer? The crust. The curve is going to be longer. Why? Because it's like this, and it's going to be longer. Now, the reason I'm saying that, now the chord's not a part of it right now. The chord's going to be an example I'll use in just a minute. But the chord is a straight line where this is curved. So if you walk, think of your tracks. Track at high school, the straightaway, and you got the people that I always thought this was weird when you start people in the inside lane. They're right here, and the people on the outside lane, they start way back here or in front. And I always thought that was weird. But why is that? Because the guy on the outside has to travel what? Further what? Further distance if he stays in that lane. Okay? See what I'm saying? And that's the part of curve. That's the relationship I'm talking about. The straight line between B and C is shorter than the curve BC. Just like your hypotenuse. The hypotenuse is always the longest side because it's covered a longer distance than the two legs. So you need to think about that because we're going to talk about that in our example in just a minute because I'm going to give you a real life example, something you'll never see until you get into traffic engineering if you get into it. But anyway, there's the chord, C-H-O-R-D, and there is the arc length. Okay? Now, there's two ways you can measure arc length. One is to measure it by theta and say the arc length is 75 degrees, or the arc length is pi over 6, or the arc length is 120 degrees. Usually, that's not practical. All right? Think about it. Academia versus the real world. What do you think is going to be measured distance-wise on arc length? Feet. You're going to measure the footage from B to C. Now, the reason it's calculated a lot is because it's very difficult to actually locate or partition off a curve in the real world. You have to actually use straight lines. Nobody goes out there and puts a stake in the middle of where a highway's fixing to go and takes a string, ties it to the stake, and takes a pin and puts dots out there on the curve. You know, that ain't the way it happens. You have to actually get out there. You have to set your theodolite here. You have to go 100 feet, pop a point, 100 feet, pop a point, 100 feet, pop a point, and then your motor grader comes in and makes that curve by using those points. So your curve is actually built by the guy that looks at the point that the surveyor engineer puts in, and he makes that curve with the motor grader. The curve is not put out there, okay, we're going to tie a point here, take a 100-foot rope, or take a 500-foot rope, and we're going to swing a line here, and then the motor graders are going to come along. That's the way it's not done that way. So there's a lot of trig that actually goes into locating a curve, because this curve is going to be, this curve is going to be, if I can think here, there's your highway, but you got to get it to connect here because you want a curve there, and you take this curve and you put between these two highways, right, or the location. This is a drawing of two highways. I'll get to that in just a minute. So the arc length can be, and you can set up this arc length by a ratio. Okay, this arc length right here, you can set it up as a ratio of theta. And the reason I'm starting from your algebra is just like I do in Calc 1. I make the transition from your algebra to the calculus. Well, I'm going to make the transition from your algebra finding the arc length, which you did in trig, I think. And you also did I don't think you did it in Calc 1 by algebra and trig, but you do it in algebra. So anyway, the relationship, and this is an important relationship, so you need to write it down, is theta over 360 is equivalent to the arc length over 2 pi r. Now, where do you recognize 2 pi r from? Circumference. So look at that relationship and see if you understand it. Because it's very important. This is a real good relationship to actually learn, because this angle right here is to 360, as this piece right here is to what? The circumference. The circumference is putting a fence around the circle, like a perimeter, where the angle is how many degrees in the middle is turned. So that's the relationship that you need to memorize for if we were in algebra, okay? Now, give you a couple examples of what you're used to dealing with algebra. Let's put one up here and refresh the algebra, and then we'll go into the calculus. But you will like the calculus today because it will actually be a refresher of stuff you've learned. And it's actually a little bit of getting into different Calc 3. Okay? So, I want to give theta. Theta is equal to 75 degrees. And I want you to tell me what the arc length of BC is. Using that relationship. All you're doing is 100% algebra. So if you can't do it, that means you what? Suck at algebra. And you can't remember your algebra back from algebra 1. Theta. Oh, I'm sorry. Radius is 10 inches. Theta over 360 is equal to arc length over 2 pi r. Now, what are we trying to find? Arc length. So we got to multiply both sides by what? Okay, so that'd be 2 pi r theta divided by 360, which 2 and the 360 will cancel and leave 180. And the reason I'm doing this is for a reason. This formula that you see right here over 180 is the actual formula that you'll see in traffic engineering for horizontal curves, for those that take civil engineering. You're going to see a derivation of it, especially the pi over 180 r theta. You'll see a derivation of that within the horizontal curves. Okay? So, what are we going to plug in? We'll plug in R is 10. So, pi times 10 times 8. I'm sorry, 75. I don't know where 8 came from. 7.5 probably. Over 180. And we can simplify that a little bit more. Take the zeros out. And then 75 pi over 18. Somebody tell me what that comes up to be. 13?
13.1.
Okay. So what is the crust length? 13.1 what? This is very applicable. Very applicable to people going into civil. Now you take this as 1,000 feet, 500 feet, then you're talking a radius of over 500 feet, and that's called the arc length. And of course, to figure the chord, you just use your trig. Well, you know and this is called delta. We'll get to that too also. All right, let's do a nerd. Yes. What? There you go. The next one, find theta if the AL is 9 centimeters. Find theta if the arc length is 9 centimeters. I'm sorry. I forgot to write that down. 4 centimeters. I put it on the picture instead of the sentence. Find theta. I'm fixing to write it on the board if you give me time. Find theta. You're supposed to go, ooh. How you do it? Ooh, I'm gonna.
I think she smirked a little bit.
Oh, she did. Oh, she is. She's crashing. Find theta if arc length is 9 centimeters and radius is 4 centimeters. If I can draw a handy dandy circle here. Really? I don't know what it is, but I figure if the radius is half of the arc length, I would suggest that this is probably what? Over 90. Obtuse. Why are you being so obtuse? What did you call me? Shawshank Redemption. This is a miracle. Man, a fart disappears like a fart in the wind. theta over 360 is equal to AL, which is 9 over 2 pi. R is 4. So multiply both sides by what? 360? That'd be a 360 over here. And that's going to be theta is equal to, take 360 out, and that'll be 180. Won't 4 go into 180? 4 will go into 180 how many times? 40, 45? So that'll go out. 45 times 9, 45 times 10 is 450, divided by 3 is 150 degrees. So roughly, probably more than 150, or less than 150 degrees. What? 129. 129. So that relationship that I showed you is quite nice to remember. And for those of you that, I got to draw this because I can't do this with a mouse. Later on, you're going to see it. It's one of my questions I got to do Thursday. We will not have class Thursday. Okay? I know that breaks your heart. But I probably will give you an assignment to do. That's the PC, PI, and for the tangent. In civil engineering, you got a road coming in, and the road, do you make the road first, or do you design the road on paper first?
Obviously, you make the road first.
Yeah, start at the wall and see what sticks.
Okay, run over fire hydrant and the cemetery. Surveyor goes out, locates all this stuff, gives it back to the engineer. The engineer designs the road around everything. And how do you go around something? Use a curve. What's your major going to be again?
Microbiology.
Microbiology, okay. So she's just going to deal with health issues instead of bridges.
Yeah.
So either way, we're all going to die. All right, so let's say you got a pond like this or whatever, and you got to put a curve right there. Okay? That's the horizontal curve. And of course, this goes out. You got to have the radius. The radius is determined upon the tangent of the curve. Actually, it's going to be right here. And this is all on paper. It's based on the tangent. This is the tangent. This is the tangent off the curve. And of course, this is just one big circle like that. But you use this part to design the curve around the pond. And this is delta, which is theta right here. But the whole point is to actually get this curve, and we've got a tangent or radius. Let's see, radius is equal to 1030. That's 1,030 feet. And let's see, the angle is 36.51. Theta is equal to 36.51. And basically, you want to find the length of the curve. You can find the length of the curve by using L is equal to what I just showed you a while ago, 2 pi r I, which I is delta, and that would be theta, over 360. Now, my whole point is showing you this little picture, and it's better drawn on here, but the whole purpose of me showing you this is that you can actually see the relationship that I just showed you from algebra in a civil engineering type question. And there it is. And you could crack that out. And of course, it's probably going to be a whole lot, it's going to be the tangent, the length, you're going to bust that in there. It's going to be 2 pi times 1030 times, I think I told you was 36.51 degrees, which that's wrong also, because in real life, you would never put 36.51 degrees. You would change it to degrees, minutes, and seconds, because the surveyor and civil engineer don't know how to turn. In the theodolite, you don't turn 36.51 degrees. So that right there is really wrong to begin with. But anyway, degrees.
So that's why we did that in trade with
Because in real life, you never, ever, ever do anything in terms of decimal degrees. Never.
those were a pain in the butt.
They were stupid. They shouldn't even be in trig. But since we have academia, and academia doesn't do anything in the real world, we change it into decimal degrees. You go out to a site plan with decimal degrees, they'll run you off the site. They will. They'll be like, what the hell is this? And I'm sorry, that's what they'll say. You go out there with pi over something radians, they'll run you off the site. You go out there with degrees, minutes, and seconds. Period. They would really like it as degrees, but the building will fall down probably because it's out of square if you don't do it in degrees, minutes, and seconds. So anyway, how does all this translate to what we're going into today? Well, you take the basics of this, the algebra, and you apply the limit theorem that we learned back in Calc 1 of take a half step toward the wall, half step toward the wall, half of half step, you never do reach the wall. Well, take that limit theory and apply it to this, and you come up with, let me just draw a dang old curve. Don't laugh at my curve.
That was just so random.
And there's the end right there. Now this could be a horizontal curve going around several things. The more curves you see, the more calculus is going to present itself, because you're not just going this little section right here, you're going as time in relation to time. So this is A and this is B. And here is your formula. The antiderivative, or arc length, they do it as L, is equal to the square root of 1 plus the derivative of f of x, which is f prime of x, squared. Now, what is different about this?
Did you purposely leave a hole on the right side and then a dot on the left side?
I just, it's like there.
I didn't know if we were doing some.
No. Good question. But what's different about this? Oh, this is A to B.
You got like a derivative and an antiderivative.
So what are we doing? We're taking the derivative of something, and then what are we doing to it? Plugging it into an integration. Welcome to Calc 3. That's what we're doing. That's what you do. In Calc 3, you've got equations, you've got formulas. And you take the antiderivative and plug it into the derivative, or you take the derivative and plug it into the antiderivative. You see what I'm saying? That's the difference between Calc 2 and Calc 3. Okay? So let's do one. I think your book has 1x to the 3/2 power. So let's do that. Let's start off with something simple so I can really mess you up by the end of class. So let's go with I think it looks something like that. Well, it doesn't look like that. Sorry. Something like this. I don't know what it looks like. But they say f of x is equal to x to the 3/2 power. And they want you to find the arc length of this. It doesn't really matter what it looks like. Most of the time, they're just going to give you a function. So go ahead and do that with the formula I just gave you.
What is A and B? 2 and 4?
Yeah, we can just put it in 2 and 4. It really doesn't matter. I don't really care. I honestly, I know y'all can do that because you got calculators. But we'll just make one up. This one is like, I have no idea what they're using in the book, but I think this one is like one of your examples in the book. Oh my gosh, I watched a movie last night that was weird. It had Billy Bob Thornton in it and Twister guy. Yeah, Twister. What's the Twister guy's name?
Bill Paxton?
Yeah, The Plan. You ever heard of that movie? Oh my gosh. It was these the 2 brothers and the brother's redneck buddy find $4 million in a plane on the farm. Crashed. And they decide to keep it until spring. And after they find the plane and everything bowls over, they can take the money and separate it. And oh my gosh, they end up all killing each other. The crazy redneck's wife, she gets killed, and I mean, it just weird.
You ever seen Interstellar?
Mm-mm.
I think you'd like that.
Huh? Ah, what is it?
It's really good. Have you not seen it?
It's got Matthew McConaughey and.
I saw it on direct. I never did get to watch it. I'll have to look at it.
It's on Netflix.
So is it that good?
It's got a lot to do with physics.
Well, I know it's about an astronaut or going in space or something.
It's got like another galaxy or something. It's like
Another dimension?
Yes. Yeah.
Oh, then I would love to go. I would love to watch that.
It's like today's version of Space Odyssey. It makes you think so much. It's ridiculous.
Like there's actually a highway going through here in the 4th dimension. Yeah. So they can't walk.
What's the name of it?
Interstellar.
It's on. You have Amazon Prime?
Yeah.
It's on Amazon Prime.
Oh, let's pull it up. I haven't pulled it up on direct too. I just never did. You know how you want to watch a movie, but you never do get to click on it? Well,
I create a list.
I'll have to. Yeah, I could do that too. All right, so the antiderivative from 4 to 2 of square root of 1 plus x to the 3/2. I'm going to put a prime on it in red. And then all that raised to the 2nd power dx. That's what you should be working on. Now you can pull the x to the 3/2 out and you can work with it and do what you need to do with it and then put it back in. You can do it in the problem. I don't care how you do that. That's just you. That's up to you. Now you have to remember, okay, how do you take the derivative? I've been taking the antiderivative so much. How do you take the derivative? Messes with your mind a little bit. What's the antiderivative of sine, Miss Anthony?
Negative cosine.
There you go. That's wrong. It changes from week to week. 1 plus, okay, that'd be what? 3/2 x to the negative, to the 5/2. Let's see. 3/2 minus 2/2 is 1/2, right? 3/2 x to the 1/2, and that is raised to the 2nd power dx. And then, of course, That squares this to what, 9/4? And that takes care of that. It takes care of that 1/2. So you got from 4 to 2 of 1 plus 9/4 x. Okay, finish it out.
Because it's writing number there, OS, which is not.
It sucks. Now, since you got to use UDU, you might have to change your do-jiggers. Or you can just do it UDU and then change it back to X and leave it as X, however you want to do it. So you got 1 plus 9/4 x. So right quick, we could pull u out, or say u is equal to 1 plus 9/4 x. So if u is equal to 1 plus 9/4 x, what would du be? Dx. So we got a 9/4 here. I'll do it in blue. Need a 9/4 here and a 4/9 here, right? Now we've got u to the what? 1/2. So the integral of u to the 1/2, or the antiderivative of u to the 1/2, is u to the what? 3/2 over 3/2? Huh? So that's u to the 3/2 over 3/2, which is 2/3 u to the, I done forgot it, 3/2. Okay, and we've got the 4/9 out front. And that's evaluated, and we're not gonna evaluate it yet because I'm gonna stick the 1 plus 9/4 x back in. So let me go up here and do that. So I've got the 4/9 times 2/3 square root, or I'm sorry, 1 plus 9/4 x raised to the 3/2 evaluated at 2 and 4. Now this comes out to be what? 8 over 27. 8 over 27. And then this, really, you could do what? The square root of this to the 3rd power. Might make it easier for you. Y'all check me. Be the square root of 1 plus 9 fourths x to the third power evaluated at 4 and 2. And 4 is going to cancel. That leaves you with 1 plus 9, which is 10. 10 to the third power is 1,000, or the cube root of, or the square root of 1,000 times 8 27ths. Y'all check me on that. That would be 4. 8 over 27. Was it the first one at 4? Is that square root of 1,000? Y'all check me? Okay, nobody's talking. What's 4?
Yes, this.
Okay, that's 9. 9 plus 1. 10 to the third is 1,000. Square root of 1,000. Minus 2. That'll be 9 halves. 9 halves plus 2 halves is 11 halves. 11 halves to the third power. I have no idea what that is, so I'll just write it out. 27 times 11 halves.
166 point.
Wait a minute, hold on. Hold on a second. Thank you. 11 halves to the third power. All right. You do this, dot, dot, dot. Somebody give me the final answer. Eight over 27 times 1,000 minus 8 over 27 times 11, 121. No, that's squared. So that's a big number. Over 8. I'll do the 2 to the third power. That's over 8. What is this? What does the whole thing come out to be? Did y'all do it? Or y'all doing it? It's the only one I didn't do.
5.6.
5.6. Yeah. Unless y'all did something totally crazy. Okay. So you can see most of the work here is what? Algebra. The stuff y'all what? Suck at. All right, so let's move on to one that makes this one look easy. Because I got to discourage you somehow, right? Why? I thought y'all would be happy about this. Y'all don't look too happy.
Because it's Tuesday morning, and it's crunch time, and we got a lot of work to do.
And I got to pile some more on you too.
Right, exactly. So we're just ready to get it to us.
Okay.
Go home
And not do it. Wait till the last minute to do it.
and we need to get home and procrastinate.
We need to get home and eat breakfast and go to sleep.
Watch Netflix.
There you go.
6 o'clock in the afternoon, and then we just start driving.
Yeah. So don't you need to wait for last week of class for that?
No.
All right, there you go. 1/3 x squared plus 2 to the 3/2 power. I'm going to give you 15 minutes to start this one. A lot of algebra.
And then you give us 30 seconds.
A lot of, and then you'll what? Quit. Throw your pencil down, make it pop.
Do that every time? No. It's 3 over 2.
Are you finished, Mr. Sanders, already?
No, I'm still looking at it.
Deciding if I'm going to do it or not, right? That is to the 3/2 power. 3/2. Now the difference between this and surface is just the formula's different. You still plug and chug. That's the difference. Surface area, dang old pottery, dang old making a area of a pot while you're making it changes. That's why I was going to show the video of pottery, but y'all kind of took over with that, with the Bernie versus Trump.
Well, you can show it now.
And Schaller being a racist, that just took over the father.
You can show that now. Well, it gives me time to think about the
No,
problem.
forget it. I'll show it to you when we do the surface area. This one's actually 25% calculus and 75% algebra. Huh?
They want people problem is now,
What's that?
I want this Jimmy Cricket religion, you know, let that conscious be you guys. Need to let that Bible be you guys.
Where did this come from? Where? Okay, Mr. Sanders, you need to get back to the problem.
I'm just saying.
I'm trying to figure out where you got that from this. You have to be daydreaming if you're not. I can't see it.
Am I not right there?
I can't comment on that because we'd have to pass the plate and then we would offend somebody and then the ACLU would get involved and you would get offended.
Oh, you ain't gonna bother me.
It was a joke. I'm still trying to figure out the correlation with this problem. You're supposed to be thinking about the problem.
Well, you're not doing well, I'm right.
You're right, Mr. Sanders.
That's what I'm just saying.
1/3 x squared plus 2, 3/2 power. What can we do here? Let's find the derivative. What are we going to do? Chain rule. Well, what's the chain rule? Well, bring 3/2 out front. 3/2. Write down what's inside. -1. And derivative of what's inside. Now clean it up. Now, hopefully y'all should have got this. What? Well, that goes out. That 2 goes out with that 2. And that leaves x times x squared plus 2 to the 1/2 power. That's part 1. Now do part 2. Mr. Schaller, what are you going to do with part 2? Mr. Schaller was right. Besides quitting, You're supposed to take f prime of x and do what with it? Plug it in. Plug it into the equation. And that's when it gets interesting for y'all. Because y'all start coming up with all kind of new algebraic laws. Y'all do. Y is equal to, I'm sorry, not Y, L. L is equal to the square root of 1 plus, sorry, antiderivative. And we're going to go from 0 to 1. Plug that in there for you. Of 1 plus brackets squared dx. And this guy comes in here. Now this is real simple if you do it in the sequence that you need to do it. Why do you say that?
Because I was in here racking my brain.
Trying to figure out how to do this. All right, well, L is equal to, basically, you're just a little bit rusty. Well, this is intimidating, but it's really not. Just square each term. Not inside the parentheses. You square this term, and then you square this term, and what happens to the one after?
So it's just gonna be x.
Yep.
Well, see, that just seemed too easy.
Well, this time, it's okay. It is easy. That's going to give you x squared.
X is like A, and then the other part.
Yeah, no.
So if you square AB, it's
You're
A
thinking
squared
of,
B
yeah.
squared.
No. This time, you're plugging into, remember, you're plugging into, so you're going to have to solve it some more. You're going to have to whittle it down because you're plugging it into something.
Right.
So whittle it down, take the square, distribute it here, take the square, distribute it here, you get x squared time plus 2. Don't forget the dx. Now what? Distribute. And now you're getting it down to something to work with. You got a bunch of parentheses and squares and stuff like that in there. You got to whittle it down. For those of you that don't know what whittle is, that is a travesty if you don't know what the word whittle means. And that is your parents' fault. 0 to 1, square root of 1 plus x to the 4th plus 2x squared. I'm about halfway through the algebra. So that means you got some more algebra to do. First thing I would do is rewrite it.
X squared plus 1 squared.
X to the 4th plus 2x squared plus 1. Don't steal the thunder, okay?
I'm sorry, I just looked at
Oh, just forget it. So L is equal to 0 to 1 of x to the 4th plus 2x squared plus 1 dx. And what does that look like? Shortcut number 1. Take the square root of the first term, x squared. Take the square root of the second term, the third term. 1 times 2 times this is 2x squared. That's a shortcut. Shortcut number 1. Remember what I told you about the shortcuts? They are never what? Never going away. Completing the square doesn't go away either. 0 to 1, square root. Oh, look at that. We've taken the square root of something squared. Will this be normal? Yes. In a lot of these problems, you're going to take the square root of something squared, and it's going to what? Take out the square and the square root, and you're going to be left with just the integration of something halfway decent. Miss Anthony, you finished yet? Oh, you say that like you're in a daze and you're trying to think while you're in a daze.
I am trying to think.
Okay. And I gotta move this up. There. All right, I'll do this for you. L is equal to the antiderivative. I'll do this for you. I'll do this thinking. That takes that out. X squared plus 1. All right, now you finish it. You should be able to do that, people. Mr. Schaller, you finished? What'd you get, Mr. Schaller? 4/3? Good job. I'm proud of you, Mr. Schaller. Racist, bigot, fascist. That's what that woman said. Did you hear what she said when he was holding the bicycle? She rode by on a bicycle. She said racist, bigot, faggot, or fascist.
But she was a Bernie supporter, wasn't she?
Yeah. He was holding up a Trump sign. Let's see. A racist is against race, and a bigot is against gender.
Biggest against
Anything?
Everything in the world.
Oh, okay.
which she was essentially repeating herself.
Yeah. And a fascist. What is a fascist?
Fascists are liberals.
It's like communist, basically. That's why I said she's.
Where in the world do people come off calling Donald Trump a
That's why I
fascist?
said she's a Bernie supporter. Wouldn't she be?
Yeah, liberal fascists.
Well, no, they say fascist is someone who's like a super nationalist, someone who really, loves his country too much. So I guess.
Oh my gosh, that's terrible.
I thought that was Baker.
I always grew up thinking that too. Oh well. But anyway, if you have no idea what we're talking about with the 4/3 and you're stuck, then let's unstick you. That's going to be L is equal to the antiderivative of x squared. You actually could do it all at one time. X to the third over what? X to the third over 3 plus x, is that right? Evaluated at, I ain't even looking at my notes, 0 and 1. And that comes out to be, what's fascist?
Is a form of radical authoritarian nationalism that came to prominence in early 20th century Europe, influenced by national syndicalism. Fascism originated in Italy during World War I and spread into other European countries. Fascism opposes liberalism, Marxism, and anarchism, and is usually placed on the far right within the traditional left-right spectrum. So
I guess I would be a little bit fascist then. I'm not right-wing nut job. I don't, dang old KKK, I don't care nothing about that. All right, let's do another one. Y'all finished with that one, or y'all need to copy some more? I'm not going to do this. I think y'all can plug in 1 and 0. I'll plug in 0 for you. If you plug in 0, what do you get?
3.
14. I think you plug in 0, you get 0. All right, y'all done? Next one. Yeah, y'all quit before you get started on this one. I'll achieve my goal. He's still looking up fascism. Or whatever, what was the word? Fascist? Yeah. I don't even know how to spell it. X squared over 2.
I probably heard that word somewhere and just wanted to use it.
Minus
Yeah.
natural log of X over 4 from 2 to 4.
Can you please extend the test date?
No. 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 Y'all had like 4 days to do it. 4 or 5 days. Why didn't you do it those days?
Couple days very long.
Okay. You'll have a chance to make it up last week of class. I'll give everybody the last week, open up everything the last week. For the 12 dead grandmothers.
If you can believe it, WebAssign.
You had 12 dead grandmothers?
No, yeah, well, yeah, no. WebAssign actually, kind of answers on my test wrong or right, because like I didn't put like under the square root, I didn't put a parentheses. And so like it marked that one wrong. Mine was in a different order, but all the signs and stuff were correct. It marked that one wrong.
Well, you didn't do it again, did you? Or did you just do it
I've done
again?
yet. I'm waiting to. kind of show
Okay,
you.
I'll take care of it. Well, we'll quit early today because I have a feeling I won't have to do, well, we're almost finished anyway. We'll finish this one and then I'll help y'all with that. Miss Anthony, how'd you do on the test?
You won't believe me, but,
You made a 5? Good.
but I only did the ones we did in class. I didn't do A.
You didn't do, oh, you just did Form C, okay.
Yeah.
Well, you're only supposed to do one, right?
You can only, I mean, you can take all 3. Takes the higher of the 3. I had to do it like that because WebAssign, yeah. WebAssign versus MyLabs Plus is a prime example of what happens when engineers design something versus when educators design something, then engineers design what they put together. That's the difference between the 2 programs.
Which one was designed by
But which one sucks?
WebAssign?
Okay, then what do you think? Who designed that one? The engineers. Because they have no idea how to teach. They don't have any idea how things work in the classroom. They're just GODs, just gods, lowercase GODs. Nothing wrong with engineers as long as you think you're a person instead of a little GOD. Right, Mr. Brooks?
Well, I guess that's right. You usually write about stuff like that.
No, I'm not. I'm right about that because I know a lot of engineers and half of them think they're the little GODs and they're not.
Well, it depends on what engineering maybe they're.
They think they know everything.
If they were industrial, then God forbid. If they're chemical or petroleum, then
there are some people that in the world that actually think they know everything. I'm just waiting for them to walk on water. When they do that, then I'll believe them.
Sounds like Dr. Gaines.
Huh?
Sounds like experience.
Yeah. I guess that's why he's teaching like me at Tri-County Tech.
Wagon is actually.
Yeah, Wagon Seal. Wagon Seal is program. Wagon Seal is the biggest dick I've known.
Who is this y'all talking about?
Like it teaches that, like engineering class at Tri-County. They've got like 4 degrees or something. Well, my PhDs, he's real smart, but
Hey, you got more.
Has he got his professional engineering license?
I think he does.
He does? Why is he teaching?
Nobody's in.
Roll it in.
He got tired of doing research, it says. He used to track like, hurricanes and shit like that.
Oh no.
Somebody was telling me he graduated from like an Ivy League school, though. So why?
You'll have to look in your handbook where all the teachers are listed and see where he got his degree from.
It don't matter to me.
He's just a dick, right?
Yeah.
Whatever. Okay. So if y is equal to this, what is y prime? Well, y prime is going to be equal to, well, I'm going to pull that 1/2 out. You can pull that 1/2 out, and then that'll be what? 2x. And then that'd be 1 to be x minus, what is this guy? Well, 1/4 can come out. Natural log of x. And what's the derivative of natural log of x? 1 over x. So 1 minus 4x, or x minus 1 over 4x. Plug that in, and you get antiderivative from 2 to 4 of 1 plus parentheses x minus 1/4 or 1 over 4x. Quantity squared, shortcut number 2, dx. Dr. Harden. That meant you know what to do here. He would skip like 15 steps. And then you get antiderivative from 2 to 4. And I did draw it out like 5 or 6 steps, but I was planning on showing y'all, but run out of time. I got, when I do everything, I got x plus 1/4 or 1 over 4x dx. Is that what y'all got? Yes, no, maybe? You're going to get x plus 1/4 x. Well, if you do shortcut number blah, 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 number 2, you're going to get x squared minus 1/2 x plus 1/16 x squared, something like that. Then if you add the 1 to it, then that comes out to be x squared plus 1/2 plus 1 over 16 x squared. And then that breaks down to x plus 1/4 quantity squared. And what is the square root of x plus 1/4 quantity squared? X plus 1/4 x. Or x plus 1 over 4x. Yes, no, maybe. You see it? And then, you know how to plug those in. I got, well, I didn't finish it because it's natural log. I got 8 plus 1/4 natural log of 4 minus 2 plus 1/4 natural log of 2. Whatever that calculates as. I'm going to give you one more to write down. This one's a little bit different. We only got one more, and that's what we would have finished today. Let me write it down for you. And the reason I want to write it down, I want you to write it down is so you can look at it because it's a little bit different. X is equal to 1/3 root y times y minus 3 from 1 to 9. What's the difference? It's basically you got the same curve or same type curve, but instead of going x is 2 and x is 4, you're going which way? Y. You're measuring it in the y direction. So you got to take the derivative of y. The formula is still the same. You just take the derivative of y in respect to x. Okay? So just take the derivative and plug it in. Okay? Now, I want to show you one more thing. And I want you to go ahead and be looking at it. And that is the next section, which is area. The only reason I want you to look at it is this. Remember I told you, this section, you plug and chug it. Look at the formula for surface area. Hold on. Look at it. What is it? 2 pi times what? F of x. So you take your function, you plug it in for 2 pi r, plug it in, and then you plug in the length of the curve right here. So what are we doing in this section? Plugging in, chugging. 25% chemistry. 25%, yeah, let's bring in some chemistry. 25% calculus, 75% algebra. So I might throw some homework problems up with this also, just let you get maybe 4 or 5 problems, just to let you get started on it. Okay, let me stop this and call the roll, and then we'll go from there.